This learning module will introduce the concept of a watershed, hydrologic unit code, and watershed studies by FEMA and other agencies. Any discussion regarding flooding should begin with an understanding of the purpose of a floodplain and why they are important. This slide depicts the floodplain, stream channel, and transitional upland fringe. The purpose of the floodplain is to store floodwaters during a flooding event. Floodplains are a naturally occurring ecosystem and are serving a purpose. The plants and wildlife that are found in a floodplain serve beneficial purposes. A watershed is defined as a region or area bounded peripherally by a divide and draining ultimately to a particular watercourse or body of water. A watershed is the area of land where all of the waters, what is under it or drains off of it, goes to the same place. John Wesley Powell, scientist geographer, put it best when he said that a watershed is that area of land, a bounded hydrologic system, within which all living things are inextricably linked by their common watercourse and where, as humans settled, simple logic demanded that they become part of a community. Watersheds come in all shapes and sizes. They cross county, state, and natural boundaries. No matter where you are in a watershed. What happens in one area of a watershed impacts all the other areas of the watershed. The benefits of a watershed study approach include that it encourages communication, coordination, and work across county boundaries coupled with a more comprehensive understanding of flooding. A watershed study approach allows for a more holistic understanding of flood hazards, resulting from more comprehensive assessments of stream and tributary relationships. It provides a framework to evaluate flood risk, engineering need, elevation data acquisition availability, and gaps in the availability of community contribution by watershed. FEMA outlined in Procedure Memorandum No. 59 the policies and procedures for FEMA watershed studies. These policies include complete, consistent, and connected flood engineering analysis within a watershed, evaluation on a HUC 8 watershed basis. Newly initiated studies will be watershed-based, and the factors to evaluate include programmatic metrics, the current availability of data, the level of risk, and the level of need. The objective of the evaluation step is to understand the risk and need data at the various watershed levels. The goals of FEMA watershed studies include the following: address gaps in flood hazard data to form a solid foundation for risk assessment, floodplain management, and actuarial soundness of the National Flood Insurance Program. Ensure that a measurable increase of the public's awareness and understanding of risk results in a measurable reduction of current and future vulnerability. Lead and support states and local communities to effectively engage in risk-based mitigation planning, resulting in sustainable actions that reduce or eliminate risks to life and property from natural hazards. Provide an enhanced digital platform that improves management of RiskMAP, administers information produced by RiskMAP, and improves communication and sharing of risk data and related products to all levels of government and the public. Align risk analysis programs to develop synergies to enhance decision-making capabilities through effective risk communication and management. The United States Geological Survey website contains a thorough explanation of hydrologic unit codes, or HUCs, which is summarized in this learning module. The United States is divided and subdivided into successively smaller hydrologic units, which are classified into 4 levels: regions, subregions, accounting units, and cataloging units. The hydrologic units are arranged within each other from the smallest, cataloging units, to the largest, regions. Each hydrologic unit is identified by a unique hydrologic unit code, or HUC, consisting of 2 to 8 digits based on the 4 levels of classification in the hydrologic unit system. The first level of classification divides the U.S. into 21 major geographic areas or regions as illustrated by the map on this slide. These geographic areas contain either the drainage area of a major river, such as the Missouri region, or the combined drainage areas of a series of rivers, such as the Texas Gulf region, which includes a number of rivers draining into the Gulf of Mexico. The second level of classification divides the 21 regions into 221 subregions. A subregion includes the area drained by a river system, a reach of a river and its tributaries in that reach, a closed basin, or a group of streams forming a coastal drainage area. The third level of classification subdivides many of the subregions into accounting units. These 378 hydrologic accounting units are nested within or can be equivalent to the subregions. The fourth level of classification is a cataloging unit, the smallest element in the hierarchy of hydrologic units. A cataloging unit is a geographic area representing part of all of the surface drainage basin, a combination of drainage basins, or a distinct hydrologic feature. These units subdivide the subregions and accounting units into smaller areas. The table on this slide summarizes the name of each level, the hydrologic unit level, digits, the average size in square miles, and the approximate number of hydrologic units for each level in the U.S. The Watershed Boundary Dataset, WBD, is a nationally consistent watershed dataset that is subdivided into 6 levels of 12-digit HUCs and is available from the USGS and USDA NRCS National Cartographic and Geospatial Centers. The new 8-digit watershed boundary dataset and the new 12-digit watershed boundary dataset are available as geodatabases for download, along with the metadata. The WBD contains the most current, highest resolution, and most detailed delineation of the watershed boundaries. EPA has an online database available on the EPA website. The web address is located at the bottom of this slide. With this database, you can locate watersheds by zip code, stream name, state, or watershed name associated with the HUC 8. With this database, one can see political offices and resources available within a watershed. This slide demonstrates a sample query of Frankfort, Kentucky, the state capital. The data includes the HUC, watershed name, congressional districts for the watershed, citizen-based groups, water quality monitoring in the watershed, impaired waters, assessed waters, stream flow gauges from the USGS, water use data, and selected USGS abstracts. This map illustrates the HUC 8 watersheds in the Commonwealth of Kentucky. There are several watersheds that are in Kentucky and surrounding states. As FEMA watershed studies are conducted in Kentucky, there is a significant effort to collect data from the stakeholders to understand local concerns regarding flooding as well as factors that may contribute to flood risk. FEMA's Risk Mapping Assessment and Planning Program, also known as RiskMAP, is taking a watershed approach to develop the non-regulatory products, the Flood Risk Report, Flood Risk Database, and Flood Risk Map, and the regulatory products including the Flood Insurance Rate Maps, Flood Insurance Study, and Flood Database. The goal for these products and data sets is for state and local officials to take actions that lead to flood risk reductions, sometimes referred to as mitigation. RiskMAP provides communities with flood information and tools to enhance mitigation plans and other management activities and better protect their citizens through more accurate flood maps, risk assessment tools, and outreach support. Conducting these studies on a watershed basis will assist the communities, Kentucky Division of Water, and FEMA to better understand the contributing factors to flooding, risks, watershed needs, and mitigation options. The watershed vision for FEMA RiskMAP states that RiskMAP will identify existing data and seek to obtain and communicate flood hazard data that increases public awareness and leads to action that reduces risk to life and property by connecting hazard mapping, hazard mitigation, and the National Flood Insurance Program through the mapping process at the community level while creating data crucial for emergency operations in the event of a natural disaster. So who uses this information? The EPA, NRCS, USGS, Kentucky Division of Water, universities, researchers, nonprofit organizations, and citizens can all use the information created by a watershed study. One of the first steps in conducting a watershed-based study is data acquisition. Some examples of data that are necessary and or supplemental to RiskMAP watershed-based studies are shown on the slide. During the data discovery process, the Kentucky Division of Water will collect data from the stakeholders. This data includes areas of recent or planned development, areas of high growth or other natural land changes such as wildfires or landslides, locations of ongoing studies, projects and studied stream reaches that have been modified since the effective map and require an updated study, such as highway improvements or locations of future topographic data acquisition, proposed discussion areas, problem areas, or areas of proposed mitigation projects, land use and soil information, and hydraulic structures such as bridges or culverts with inspection status if available. This slide illustrates some of the participants in the discovery process: local agencies, area development districts, FEMA, Kentucky Division of Water, the Army Corps of Engineers, Emergency Management, Transportation Cabinet, and state and federal elected officials. The discovery of available data would include investigation of available topographic data, aerial imagery data, engineering studies, and other data useful for the production of Risk MAP products. Regions are to make use of partner-supplied data wherever possible. Applicable data includes inundation areas, clusters or locations of assistance grants, locations of projects and structures completed or planned, whether the community has received, is currently using, or intends to apply for federal grants to achieve mitigation planning, current community plans, ordinances, or programs to alleviate flooding. This slide contains data collected through the discovery efforts in Kentucky from the Big Sandy Area Development District's Hazard Mitigation Plan. The table illustrates structures and the value of structures in the Big Sandy Area Development District's service area that could be impacted by natural hazards. The map illustrates the number of flooding occurrences by county from 1975 to 2009. This data is valuable for the RiskMAP risk analysis. This map illustrates areas of future development in the 5Co Area Development District service area. This map is beneficial for future planning efforts and mitigation efforts. Additional data and documentation is reviewed for each watershed, such as FEMA-approved hazard mitigation plans, previous flood hazard studies, the number of flood insurance policies and claims, letters of map amendment or revision, averaged annualized loss information, census data, federal disaster information, and levee and floodwall information. There are 3 phases to a riverine flood study. The first phase is to assess the flows, which is called hydrologic study. A hydrologic study is the study of movement, distribution, and quality of water. The second is to determine flood elevations and the floodway, which is hydraulic analysis. And the third is to map the floodplain, or the special flood hazard area, and the floodway. Floodplain mapping pre-RiskMAP generated 3 types of products: the FIRM database, the flood insurance study, and the flood insurance rate map. These were all regulatory products used for floodplain management and to establish mandatory flood insurance purchase requirement. These products will continue to be generated from the FEMA watershed studies. The non-regulatory products being created through RiskMAP watershed-based studies include the Flood Risk Database, the Flood Risk Map, and the Flood Risk Report. These products do not seek to replace the regulatory products such as the FIRM, Database, Flood Insurance Study, and the FIRM. Those will continue to be produced for each studies. The new non-regulatory products are intended to provide additional information to increase flood risk understanding and awareness, risk communication, collaboration, and mitigation. This slide shows an example of a discovery map. Discovery maps include the following information: areas of mitigation interest, community information, loss information, floodplains, National Flood Insurance Program dates, and provides a visual representation of data collected from discovery. Flood depth and analysis grids datasets provide a wide variety of information associated with determining and visualizing flood risk. Examples of the multiple datasets are shown on this slide. The flood depth grids can be developed for the 10%, 4%, 2%, 1%, and 0.2% annual chance flood events, also known as the 10, 25, 50, 100, and 500-year floods. In addition, the percent chance of flooding in any given year and the percent chance of flooding during a 30-year period can be communicated. The features and benefits of these datasets include identifying the relative risk within the special flood hazard area, indicating the percent annual chance of flooding over an average mortgage time period, assisting with mitigation prioritization based on risk, assisting with cost-effectiveness screening for potential development, and creating a visual tool to communicate risk to the public. The intended users for the flood depth and analysis grids are planners, officials preparing mitigation grants, elected officials and local leaders, homeowners and home buyers, and realtors. These datasets can help communities better understand more characteristics of their floodplain, in addition to the standard 1% annual chance flood zone information. It visually shows a level of risk within the same floodplain and depths of flooding for multiple return frequencies at any location. It's a powerful communication and planning tool, enabling users to convey that a property may not just be in or out of the 100-year floodplain, but that it may receive a specified level of flooding from an event of lesser magnitude. Using the depth for a 25-year event, simple depth to damage curve calculations can be applied to tell a particular property owner that a particular event they can expect a specified amount of dollar damages. The flood depth and analysis grids can also assist with enlisting the support of elected officials and local leaders by identifying areas of highest flood risk according to frequency and magnitude for possible mitigation actions, even if the action is to maintain open space. They can also help building officials, property owners, and developers understand the elevation requirements for specific sites according to local flood damage prevention ordinances and how those may change over time. The depth analysis grids on this slide represent the percent annual chance grid and the likelihood of flooding during a 30-year mortgage. The percent annual chance grid projects the risk of flooding in any given year. The likelihood of flooding during a 30-year mortgage period illustrates the risk of flooding during a 30-year mortgage. The ultimate goal for the watershed projects is to provide decision makers with the tools to take actions and mitigate risk. If more is understood about the watershed, then decision makers will be able to make more informed decisions regarding development, sizing and location of infrastructure, and how these impact neighboring communities in the watershed. This concludes our module on watersheds-based studies. For more information, please visit the sites on this slide.